This session we are going to discuss about geometrical meaning of scalar triple product. What do you mean by geometrical meaning of scalar triple product? First of all, we must know what is scalar triple product. Scalar triple product is defined as a vector cross b vector dot c vector. Here we must know this a vector cross b vector should be inside the bracket and c vector should be outside the bracket. If we cross two vectors, we'll get another one vector. That vector alone can be dotted with another one vector. So to get this type of products, we need the cross should be inside the bracket. This is called scalar triple product. Even we can write this as a vector dot inside the bracket we can put b vector cross c vector. That is also called by the name scalar triple product. Before going to find what is the meaning of scalar, what is the geometrical meaning of scalar triple product, first let us recollect what is a vector dot b vector and what is a vector cross b vector. Right, we know a vector dot b vector as modulus of a vector modulus of b vector cos theta. This theta is nothing but angle between a vector and b vector. Right, and we know a vector cross b vector is nothing but modulus of a vector modulus of b vector sine angle between these two vectors, this theta. Here the n cap is direction of a vector cross b vector. That is, this direction, this a cross b direction is perpendicular to both a vector and b vector. This direction n cap, because this is unit normal vector, this is the direction of a vector cross b vector. This is perpendicular to both a vector and b vector. And if we take modulus to this, we'll not get the direction. So modulus of a vector cross b vector is nothing but modulus of a vector modulus of b vector into sine theta. Now let us jump into the geometrical meaning. A vector cross b vector dot c vector is called scalar product, or it is also called by the name box product. At the end of this session, you can understand why it is called by the name box product. Let's write this definition of a dot b and a cross b and modulus of a vector cross b vector. We know that modulus of a vector cross b vector is modulus of a vector modulus of b vector into sine theta. You know, the geometrical meaning of this is nothing but modulus of a cross b's geometrical meaning is nothing but it represents a parallelogram's area. So modulus of a vector cross b vector is nothing but area of a parallelogram whose sides are a vector and b vector, whose adjacent sides are a vector and b vector. Okay, by keeping all these things in our mind, let us try to find the geometrical meaning of a cross b dot c. First of all, let us try to find what is a vector cross b vector. Right, for this let us draw a diagram. Let this be our O, and this is a vector a vector, this is our a vector. Now let us draw b vector again from the same point O. Now this is our b vector. Let us consider this point as capital B and this is our b vector. O to B is our b vector. Right, so we have drawn this a vector and b vector. Now as we know very well, if you cross this a vector and b vector, these two are the adjacent sides. Okay, if we cross this a vector and b vector, according to the geometrical meaning, we know that we'll get a parallelogram. So using this two sides, let us try to complete the parallelogram. So this is what that parallelogram. This parallelogram is our a vector cross b vector's magnitude. Right, so this is our a vector cross b vector. And as you know, as I told you, this n cap is nothing but this is a normal vector to a vector and b vector. So we have drawn a normal vector to a vector and b vector. So this is the direction of a vector and b vector. Already you know what is a vector cross b vector and we know its magnitude. So now it is our duty to find its direction, where the force goes. So according to the definition, we know that this a vector cross b vector will be a normal vector to both a vector and b vector. So this is our normal vector to A vector and B vector. So this is our A vector cross B vector. This A vector cross B vector is perpendicular to both A vector and B vector. So simply we can say this is perpendicular to this parallelogram itself. Right. Now we have completed the work of A vector cross B vector. Now we have to dot this with C vector. So let us try to draw a vector again, C vector. Let us consider that we are going to draw here, and there will be angle between this A vector and B vector, sorry, A cross B and C vector. Let us consider that angle as phi. So let us draw it. This is our C point, this is our C vector, and we have considered angle between these two vectors, because now A cross B is a single vector. Angle between these two vectors as phi. Right. We have completed up to this. Let us see the definition of A cross B dot C. This A cross B is now single vector. We are going to dot this A cross B with C vector. So let us go to the definition of dot. A dot B is nothing but modulus of A modulus of B cos theta. That is modulus of first vector modulus of second vector into cos of angle between these two vectors. So if we consider this, modulus of first vector into modulus of second vector into cos of angle between this vector and this vector. So angle between this vector and this vector is nothing but phi. So A cross B dot C is modulus of A cross B into modulus of C vector into cos phi. Right. Moreover, we know the geometrical meaning of modulus of A cross B. That is nothing but area of this parallelogram. We know this. So we can write this as area of parallelogram into modulus of C vector into cos phi. Right. Now everything is okay, but let us try to bring the meaning for this modulus of C vector into cos phi, because we know the geometrical meaning of this part. So modulus of C vector, that is very known one, because modulus of C vector is nothing but the distance from O to C. So this is what our modulus of C vector. So that is not a matter. Now the problem is with cos phi. Let us try to find some meaning for this cos phi. Better, let us try to bring this phi near to this parallelogram. For that, let us do one thing. Let us draw a straight line parallel to this A vector cross B vector from the point C to this parabola. Now it is drawn. Since these two lines are parallel, if this line is perpendicular to this parallelogram, surely this line will be also perpendicular to this parallelogram. Right. Now we know these two lines are parallel. According to the rule, if the two lines are parallel, then the alternative angles will be equal. If this is phi, then this will be also equal to phi. Right. Now we have to find cos phi, so we need a triangle. Let us join O with this particular point, and let us consider this point as E. Yes. That's good. So we have drawn a triangle. For this triangle, we are going to find cos phi. This is our angle, so this will be our opposite side. And this side is opposite to the perpendicular angle. So this side will be our hypotenuse. So this is our opposite side, this is our hypotenuse, and then this will be the remaining side will be our adjacent side. Right. Now let us try to find cos phi in the triangle OCE. In this triangle OCE, let us try to find cos phi. Cos phi is equal to adjacent side by hypotenuse. As I told you, our adjacent side is CE and our hypotenuse is OC. OC is nothing but length of C vector. Length of C vector, that is modulus of C vector. CE is just height. Because these two lines are parallel, this line is perpendicular to this parabola, sorry, this line is perpendicular to this parallelogram, hence this line will be also perpendicular to this parallelogram, hence this is a perpendicular height. So we have written that as, marked that as H. If this modulus of C vector comes, this side will become as multiplication. So modulus of C vector into cos phi is equal to perpendicular height. Now consider this. Already we know the geometrical meaning for modulus of A cross B, that is area of parallelogram. Now we have received some geometrical meaning for modulus of C vector into cos phi, that is perpendicular height. So if we consider it, if you consider this is base, this is base area, that is area of the parallelogram, and this is height. This is not simply height, this is perpendicular height. So as you studied in the earlier classes, you know, if you multiply the base area with that perpendicular height, we will get volume of that structure. So using these three sides, we have to bring that structure. What structure we'll get? For this, we have to draw a line parallel to this line from this point. Then we have to draw another one line from this C like this. So if we complete it, we'll get another one parallelogram in the top. So let us try to complete all these things, and let us try to see what is the structure we are going to receive now. So if we complete this, yeah, we are getting a structure like this. So this is what the structure, for this structure only we are getting the volume. So now it is clear, A vector cross B vector dot C vector is nothing but volume of this structure. A cross B dot C, this A cross B is area of parallelogram, and this dot C, this for this dot C, A cross B dot C, according to this, instead of this modulus of C vector into cos phi, we have written H. So A cross B dot C is nothing but area of parallelogram, or the base area into height. It gives the volume of this solid. This is just like a box. So we used to call it by the name box product. I hope so you would have understood it. Thank you for watching this video. Thank you.